Hello. So we are continuing to develop our to-do list web application written in C. So in the last video we have done some refactoring work and fixed some memory leak issues. So it's time to add our next feature, which is the ability to handle multiple paths and to respond back to the client. So I would like to have an interface which is pretty similar to other web frameworks like Python Flask or Node.js, ExpressJS, or even Go Gin. So I would like the ability for the calling method to be able to define the handler functions, where there will be some helper functions to be able to return the JSON back to the client, and probably also some helper functions to be able to parse the headers, which we already have, but I'm talking about a function to get a header value given the key, and also some helper functions to convert to JSON or parse from JSON, get some path parameters, etc. So let's start with the basics. All right. So we need the ability to define a handler function here. So let's make it similar to other frameworks out there. So for that we need a function pointer. Type def. So this will not be returning anything. Let's call it request handler func. Okay, I think that's clear. And it's gonna take a request as a parameter. So essentially, in the main function, we can define the handler functions for different paths, and inside that, we are going to pass the request object, and the handler can decide what to do with it. Let's also define some constants for the methods. Hash define so we'll have to repeat this everywhere, so it's better to keep that here. Get post delete patch put. Is that it? Head. Okay, we'll add it more if needed. Okay, perfect. Then we need the ability to add attach handlers. So let's say web server handle get. Okay, so this will attach a get handler. So what do we need? It needs a web server as a parameter, of course, and a path. So this is always gonna attach to the get method, so we only need the path, and of course the function handler. Okay, so this will attach a handler function to the get method with the given path. Okay, let's repeat that. For post delete patch and put, what else, head. Get post delete patch put head. Okay, perfect. Now that's out of the way, let's implement this in our web server. Okay, so we need to modify our web server to keep track of all the handlers. So that's the first thing to do. So for that we need an array of handlers. So in this case I would like to make a dynamic array instead of having it static or having a linked list or something like that. So, and we also need a struct to hold the handler function, the corresponding details together. So let's create a struct for that first. Struct, let's call it request handler entry. This will be an entry which contains a handler and some other parameters. Let's say request handler. Okay, we also need to keep track of the path which this handler is handling and also the method. Okay, so this is a handler for this particular path and this particular method. Okay, and in the web server we need to have an array of entries. So request handler entry handlers. Okay, actually pointer to handlers, which is going to be a list of handlers. Okay, then we need to keep track of the number of handlers. Okay, so one thing we can do here is we can specify, so during the initialization itself we can specify the number of handlers and initialize that much memory here, or another option is to allocate some capacity, and whenever there is a need we can just reallocate it to a bigger array. So let's do that. Size t capacity. This is probably an overkill, but it's fine, no big deal. So okay, so we have the space for that. Now in the web server create method we'll have to set initialize this, so handlers count will be 0. Capacity, so initially I would say let's add the capacity of 10. Of course we are going to dynamically increase it when needed, and we have to initialize the handlers. So okay, so this is going to allocate 10 entries here. Okay, let's do a make and see what we missed. Unknown type name request. Okay. Okay. Huh. Actually, we'll have to move the definition of the request structure here because this will be used everywhere. Okay. HTTP header. Okay. This should be here, and this should be here. Okay, now what? C14. Request handler function. Handlers capacity. No member handlers capacity. Instruct web server. Of course, this should be handlers capacity. Okay. 61 have 2 arguments. So this should be multiplied by. Okay, so far so good. So we have initialized the handlers. Now we need the ability to attach handlers. So you know what, we have these many handlers, but we can just have one function which will take method as an argument and all of this using that function inside it. Okay, that's easier. So web server handle we need to define here. Let's call it web server handle. So this will take everything into this, and also the method. Okay, it's time to implement this. So first of all, we need to check the capacity and add more capacity to the array if needed. So let's do that first. So handlers count greater than equals to handlers capacity. Let's multiply that by 2. So whenever we are near the capacity limit, we are just going to multiply by 2 and have space for more. So handlers equals to, we need to reallocate this to handlers. Okay, so now that we have the capacity in the array, so to find the index, let's keep it in a variable, we will need it, equals to handlers count. So we'll be adding to this position in the array. Handlers I dot method equals to method path. Okay, okay, so we have attached the function and stored it in the web server object. I keep calling it as object, but you know, I mean structure. So similarly, we need to implement the handle get post. So inside this, all we had to do is pass it along to web server handle server path handler method get. So get post put delete patch. So this will be get post put delete patch head. Okay, so we have 3 4 5 6. Okay, that's it. And don't forget to modify this. Post put delete patch and head. Okay, compile, all good, great. So now what do we need? So here, let's go back to our run method. We have the connection, we have the request parsed. So as soon as we parse the request, we have the method headers and everything. So here we have to now find the corresponding handler for this particular request and then delegate it to that handler. Okay, so before we do anything here, let's use the interface first, so this will give us a better idea. Okay, so we need to have a couple of handlers. Let's say handle get to dos. We are implementing a to-do list API, remember. So let's add a couple of get to dos and post to dos. Okay, so what do we do when we get to dos? We just say printf getting to dos. Okay, this is just a dummy method. We'll enhance it later. Posting to dos. Okay, and web server handle get. Okay, so this will use pass the web server parameter, path, and the handler. Okay, so web server, let's say /API /to do, and handler get to do's. So same way post. So basically we want this server, whenever there is a request to /API /to do with the get request, it should execute this method. Okay, so eventually we can have some complicated logic here to send a response back to the client. Let's hope it works. Okay, some warnings. Curl to do nothing yet because we haven't implemented that part yet. So, but there are no errors, which is good. Going back here, so we need a method to loop through this entire list of handlers and find the one which corresponds to the request. So let's add a method for that. So basically it needs to return a handler func. Let's go to request match handler. Okay, and it will take request as a parameter. So you know what, we are sending the request object into the client here, so we might as well have the web server object embedded inside this, so that here in case we need to close the request, close the server or something like that here. So that means we only need to pass a request parameter here, no need to pass the web server separately. So in the request we need to keep track of the web server. Okay, so and before we forget that, let's also isn't it WS? Yep. Okay, all right. So coming back to the implementation of the match function, let's take the web server object out, because this is where we have the array of handlers, and loop through the handlers count. Okay, so we are looping through the handlers here. Let's do a string compare of the handlers I dot method. So the method of the handler should match the method in the request. This should be 0. And for the path it's much more complicated, because if we have path like a API to do /1, it needs to match something like this. So this part can be dynamic, but for now let's keep it simple, and let's replicate the same behavior for the path as well. So to do enhance later. Okay, return. Okay, so this will return the handler function. In case nothing is matched, we'll just return null. Okay, so this will return the corresponding handler function given a request. Now what we need to do here, let's get rid of all the print statements. We don't need this anymore. Okay, so this will return the matching request handler function, and of course we need to check if it's null. Oh wait, I forgot to add the variable. If handler, we just call the handler with the request. So the corresponding handler will be executed passing the request, and else we need to come on. Okay, so if we, in the else case, that basically means it's a 404, so that has to be implemented here. We'll do that later. Let's see if it works. Request handler entry from function with incompatible with okay, so that's because this is an entry, we need to return the handler. Okay, so we are getting the response getting to do's, and if we do a post request, where are we? That's not working. And why is that? Handle get, handle post. Okay. While we are here, let's do a /n. Okay, posting to do's, getting to do's. Perfect. So our handler methods are working, handling is also working, and let's add a little bit of logging here so that we know what's happening. So right now we have the request printf got request. This will be the method and the path. So we got rid of all the printing of headers and body and stuff like that. So this is just for logging purposes, which will be quite useful even in the later stages. Okay, so whatever request we make, we are getting it in a pretty standard format. That's good. So now that we have the request handler ready, let's try to return some text back to the client, shall we? So for that, I would like to have a couple of helper functions. So we haven't got to the part where we can write JSON messages yet, but let's assume that we are sending back just a text message. Okay, so for that, let's add a method request send text. So this will allow the user to return a text back to the client. So this will take a request as a parameter and a response. Okay, so what we want is, in the main function, we want this user to be able to use this method request send text, send text hello world. All right, to implement that here, what else do we need? So we need to send back the response in a HTTP format. Let's try HTTP response format. HTTP. Okay, so the start line will be the same as the one which we have in the. There should be a version number, error code, and some headers, an empty line, and the body. Okay, status line should have the headers. Okay, let's forget about HTTP 2 now. We are only working with HTTP 1. Okay. Interesting. So we have the response from the user here. Actually, let's send it to text. So the user is sending back an empty text. It's not HTML, it's not JSON, it's just text. Okay, so that means, actually let's also add a parameter of status code. Status. Okay, so request status hello world. Okay, we have the status here. Now we need to form the response. So for the response, we can do sprintf. Actually, I forgot how sprintf looks like. Sprintf takes a character string and then format buffer. Okay. Interesting. So we need to create a response array. Let's say malloc. I think that should be pretty much enough. Don't forget to free this afterwards. Okay, so we are sprintf response and okay. Looking at the spec again, we need the header which will contain HTTP version. Okay, let's hard code it to http/1.1. okay, and then the status code /d, then the status string. Here it is forbidden and no line. Okay, nothing It's mentioned about a slash n or slash r, but I'm assuming that we need a slash r slash n here. So http slash version, okay, slash r slash n, and then we have the content type. Let's give it a content type, and what is the content type? HTTP content type text. Examples: text JavaScript, text CSS. Okay, we have it here. XHTML, JSON, XML, MPEG, image, application. Okay, text HTML, text plain. Okay, that's what I was looking for. We need text plain. Okay, I think that's the only header we need. Then what else? Can we add a multi-line string like this? I hope so. And then we have the whole text from the user. Okay, and then afterwards we need a slash r slash n again. Okay, now the parameters, the status. Okay, we need a status text which I will write soon. Then the text, is that it? So status text, and the text itself. Okay, castar status text equals to okay. Eventually we'll have to check what's the status here and give a appropriate status text. To do handle other status check types. Okay, and then we write it back to the client. So request client FT, yes. Hope it works. Where did I miss a semicolon? Everywhere. No member named client FT. Did we forget that? Yes, we did. Of course, how can we write back without having the client file description? Okay, client FT. Okay, ignoring the return value. Alright, that's okay. Aha, look at that. Let's try this in the browser. So we are going to try in the browser for the first time. Awesome. Let's take the network tab and make sure everything is as expected. Huh? Ah, okay. Awesome. So request headers, response headers have just the content type, nothing else. Awesome. Okay. So that's it for this video. So we have a way to send back text to the client. We now have the handler functions. So I think we can stop right now. In the next video we can see how we can implement some advanced features like JSON parsing, sending JSON back to the client, and also things like how to do HTML templating and things like that. I think it's getting pretty exciting. We are almost getting there to have something usable. So we are able to send back some text right now. So we can just enhance it and add the ability to send back like a JSON array of to-do list and some CRUD operations, adding deletion, etc. Eventually we might even add some like file-based database or something like that, and maybe some UI. Why not? Okay, so we were able to learn a lot of things about how HTTP work, how C works, how memory allocation works, the format of HTTP, a lot of things. A lot of things have been new to me as well. I'm handling multiple C files, having custom header file and everything for the first time as well. So I'm also learning along with you. So thank you for following along. Hope you're enjoying this. See you next time.